Welcome to our deep dive. We're going to explore volcanic bombs. You know those fiery projectiles launched from volcanoes?
Definitely fiery.
We're going to look at how they form, the crazy variety of shapes, and what they tell scientists.
They really can reveal quite a bit about a volcano.
Plus, we'll even see how knowing about them affects us.
Well, hopefully not too directly.
Haha, yeah, true.
Yeah,
But, just the general danger element adds a bit of excitement, wouldn't you say?
absolutely. Volcanoes are fascinating.
Okay, so to kick things off, could you remind us what exactly makes a volcanic bomb? I mean, I know it's not just any rock a volcano spits out.
You're right. It comes down to size and state. To be a bomb, it has to be bigger than 64 millimeters. So picture a golf ball, but often way bigger.
Okay, got it.
And importantly, it's got to be at least partially molten when it's launched. That's what lets them form those wild shapes as they fly through the air.
Like fiery sculptures almost.
Exactly.
We're talking molten, or at least semi-molten, rock, sometimes bigger than a basketball, flying through the air. That's pretty dramatic.
Oh, for sure. And there's a whole system for classifying them.
Like a field guide to fiery projectiles.
Exactly. And just like a guide helps you with birds or plants, knowing the bomb types helps scientists understand the eruption.
Intriguing. So what are some common shapes, and what can they tell us about what's going on inside the volcano?
Well, one striking shape is the ribbon bomb. It's long and stretched out, almost like taffy.
Okay, I can picture that.
They form from fluid magma. Imagine something with a honey-like consistency. As it's thrown out, it stretches, and surface tension helps make it thin.
So runny magma, ribbon bomb. What about thicker magma? What kinds of bombs do we get from that?
Think peanut butter. That's what viscous magma is like. It doesn't flow easy.
Ah, so it doesn't stretch out nicely like the honey example.
Right. Instead of stretching, it tends to make irregular shapes.
Like those cool bread crust bombs I've seen pictures of?
You got it. That cracked surface tells you the magma was viscous. The outer layer cools and hardens, but inside it's still hot and gassy and expanding, so it cracks the crust.
Wow, so it's like a mini eruption happening inside the bomb itself.
Kind of, yeah.
Okay, so ribbon bombs from runny magma, bread crusts from thicker. What other shapes should we be looking for?
Well, there are spherical bombs, basically blobs of lava that cooled into almost perfect spheres. Surface tension at work again.
Makes sense.
And then you have spindle or almond-shaped ones. Those form when the blood of magma is spinning as it's ejected.
Like a fiery football.
Exactly.
So just by looking at the shape, we can tell how it formed, and even something about the magma. That's incredible. But I mean, we've got to be real here. These bombs aren't just curiosities, are they? They're pretty dangerous.
Absolutely. We're talking about molten rock being hurled with a lot of force. They can travel for kilometers and cause a lot of damage, depending on their size and speed.
I remember reading about the eruption of Galera's volcano back in '93 in Colombia. Sadly, some scientists were killed by volcanic bombs.
Yeah, it's a tragic reminder of how dangerous they can be. And even a smaller bomb can be dangerous.
That's scary to think about.
It was during the Kilauea eruption in 2018 in Hawaii. A basketball-sized bomb landed on a tour boat and injured over 20 people.
Oh, wow, that's terrifying. So while we might be fascinated by these volcanic bombs, we've got to respect their power. But beyond the danger aspect, what makes them so interesting to scientists? I mean, what can they actually tell us about volcanoes?
Well, for one thing, they give us a peek into the volcano's plumbing. Remember those cord bombs we talked about, with the older material wrapped in fresh lava?
Oh, yeah? Like a little time capsule.
Exactly. By analyzing the core, scientists can learn about the rocks beneath the surface and even get clues about past eruptions.
They're bringing us samples from inside the volcano. Is there anything else they can tell us? Like, can they help predict future eruptions?
They actually can. Remember how the bomb shapes are linked to magma viscosity?
Yeah.
Well, if scientists see a shift in the types of bombs during an eruption, it could mean the magma is changing or conditions inside the volcano are shifting.
Ah, so it could be a warning sign that things are changing and maybe a more explosive eruption is coming.
Right. It's like the volcano is sending us a message.
In the form of molten rocks.
Yeah, pretty much.
Yeah.
And if we can understand that message, we can better assess the risks and maybe save lives.
This is all so fascinating. I never knew we could learn so much from these bombs. So how do scientists actually study them? Do they just go out and collect them after an eruption?
Well, field work is definitely a big part of it.
I bet.
They'll carefully map out where the bombs landed, measure their size, and document their shapes.
Makes sense.
But they also use high-tech tools to get a better understanding.
Like what? Tell me they use lasers.
Well, lasers are used for some remote sensing, but for volcanic bombs, thermal imaging is really useful.
Oh, okay. Like those heat-sensing cameras you see in movies.
Exactly. Thermal imaging lets scientists see the bombs while they're still hot.
Ah, that's so cool.
And it can also be used to track lava flows in real time. That's really important for monitoring eruptions and figuring out the hazards.
Wow, so they're actually tracking these bombs. What else do they do?
Well, they take them back to the lab, of course.
Makes sense. What happens at the lab?
That's where the real detective work starts. They'll analyze what the bomb is made of to understand the type of magma and what was happening inside the volcano.
Wow.
They'll also look at the texture under a microscope to learn about its cooling history.
So each bomb carries a record of its journey from inside the Earth to the surface.
Exactly. And by piecing together those records, scientists can start to understand the story of a volcano.
That's amazing. We've covered so much,
Right.
from shapes and dangers to how they're used for research. But before we get too deep, I think we need to step back and consider why anyone should care about these volcanic bombs. Like, why does it matter to the average person?
It's a great question. I think there are a few reasons. First, they're a reminder of how powerful volcanoes are.
Yeah, we tend to forget that until we see those pictures of molten rock being thrown around.
Exactly. Second, understanding these bombs helps scientists assess the risks of future eruptions. They can use the information to better protect communities that live near volcanoes.
So it's not just about scientific curiosity.
Mhm.
It has real-world applications.
Absolutely. And finally, let's be honest, they're just really cool.
True. They spark our curiosity and remind us of the power of nature.
I agree.
Well, we've covered a lot already. But there's still so much to learn about volcanic bombs. We'll be back with part 2, where we'll dive even deeper.
Looking forward to it. Welcome back to our deep dive into volcanic bombs. Ready for more?
Oh, absolutely. Last time we were talking about how those bombs can help scientists figure out what's going on deep inside a volcano. I mean, you said they can even provide clues about past eruptions. That just blows my mind.
It is pretty amazing, like having a time machine almost. You know, those bombs can actually help us reconstruct those past eruptions.
Really? How does that work?
Well, imagine a detective at a crime scene. They're looking for clues, anything to piece together what happened.
Yeah, I get it.
It's the same with volcanic bombs. Scientists carefully map out where they landed, how far they traveled, what size they are.
Oh, so a bigger bomb means a more powerful eruption.
You got it. And the direction they're scattered can tell you which way the blast went.
Like putting a puzzle together, but with molten rock.
Exactly. Scientists can figure out the force of the blast, how high the eruption was, even which way the wind was blowing.
So the more we know about past eruptions, the better we can figure out what a volcano might do in the future.
Right. If a volcano has a history of big eruptions and bombs flying everywhere, that's important to know.
Makes sense.
Yeah.
So it's not just about the bomb itself, but how it fits into the whole story of the volcano.
Yeah. And speaking of the big picture, they actually play a big role in shaping the landscape.
That's right. We've been talking about how they can fly for kilometers. Over time, all those eruptions must really change things.
Oh, absolutely. Think about it. Countless bombs raining down over thousands, even millions of years.
Wow. So it's not just one bomb's impact, but the total effect over time.
Right. They can actually create some pretty impressive features, like scoria cones.
Scoria cones. Isn't scoria that dark, holy rock you see around volcanoes?
You got it. It's full of holes from gas bubbles escaping as the lava cools. And volcanic bombs are often made of scoria, so they're basically the building blocks of these cones.
Okay, so imagine a volcano erupts, throws up all these scoria bombs, and they pile up around the vent. Over time, you get a whole hill, or even a mountain. It's like nature's 3D printer.
I like that. And they don't just form cones, they can get stuck in lava flows too.
As the lava spreads out, it carries them along.
Yep. And then they become part of the rock when it cools. They're also found in those layers of volcanic stuff that spread out for miles.
So they become part of the landscape, adding to all the texture and shapes.
Exactly. It's amazing to think something so chaotic can create such lasting features.
It really shows you the power of geology. These eruptions might seem random, but they're part of a much bigger story.
A story that's still unfolding over millions of years. And volcanic bombs are one of the key players.
They remind us that even the most destructive forces can create the world around us. You mentioned earlier that scientists are using technology to study them. What are some of the coolest tools they're using these days?
Drones are a game changer.
Oh, really?
Yeah, they can fly over dangerous areas, take high-resolution pictures, even collect samples. It's like having a bird's eye view of the volcano, but you're nowhere near the danger.
That's amazing. What about computer models?
Oh yeah, those are getting really good too. Scientists can simulate eruptions and see how bombs are ejected.
So they can study the physics behind it and make better predictions.
Exactly. It's a combination of field work, lab work, and high tech that's helping us learn so much.
It's really quite remarkable. We talked about the dangers of volcanic bombs before, but I think it's important to mention it again, especially with how popular volcano tourism is becoming.
Absolutely. It's great that people want to experience these amazing places.
For sure. But they need to do it safely.
Right. So, first and foremost, always listen to the local experts. They know the area best.
They can tell you about any activity and keep you updated on safety.
Exactly. Stay on marked trails, pay attention to signs, and never go where you're not supposed to.
It's not worth the risk, right?
Definitely not. And remember, those bombs can travel really far. Even if you think you're far enough away, you might not be.
So what else should people be aware of?
Keep an eye out for any changes in the volcano. More gas, swelling of the ground, or changes in earthquakes can all be warning signs.
Yeah. So if you see something weird, report it right away.
Yep. Basically, be observant, be aware, and put safety first.
I like that. Safety over a cool photo op.
Exactly. Never underestimate the power of nature. Volcanoes are amazing, but they demand respect.
Well said. I think that's a good place to wrap up this part of our deep dive. We've gone from shaping landscapes to staying safe around these powerful places.
It has been a fascinating conversation.
Welcome back to our deep dive on volcanic bombs. We've been exploring their formation, shapes, and how they can tell us about a volcano's history and hazards.
It's been quite a journey for sure, from those fiery projectiles flying through the air to how they shape the landscape over time.
You mentioned last time that scientists are using some pretty cool technology to study these bombs. I'm curious to know more about that. What are some of the tools they're using to uncover these volcanic secrets?
Well, one of the big game changers is drones. They can be equipped with high-resolution cameras and all sorts of sensors.
So they can fly over dangerous areas, get a clear view without putting people at risk.
Exactly. They can map out where the bombs landed, collect samples, even create 3D models of the landscape.
That's amazing. It's like having a bird's eye view of the volcano, but from a safe distance. What about computer models? Are those being used too?
Oh, absolutely. And they're getting more sophisticated all the time. Scientists can now simulate eruptions and study how those bombs are ejected and spread out.
So they can study the physics behind it and maybe even predict future eruptions more accurately.
Exactly. It's a really exciting time to be studying volcanoes. And it's not just about the high-tech stuff. Scientists are using innovative techniques to analyze the bombs themselves, too, like X-ray microtomography.
X-ray microtomography, that sounds complicated.
It is, but basically it's like a CPAT scan for rocks. They can create 3D images of the bomb's internal structure.
So they can see inside the bomb without breaking it open. That's incredible. What kind of information can they get from that?
They can see how the crystals and bubbles are distributed, which tells them about the conditions when the bomb formed. They can even find tiny fragments of other rocks trapped inside, which gives them clues about the volcano's plumbing system.
Wow, that's mind-blowing. It's amazing how much information is packed into something as seemingly simple as a volcanic bomb.
I know, right?
Hmm.
It really shows how even the most destructive forces of nature can help us understand our planet better.
You mentioned earlier that this knowledge can help us mitigate risks and potentially save lives. Can you expand on that a bit more?
Sure, by studying bombs from past eruptions, scientists can create hazard maps showing areas most likely to be impacted in the future.
So it's not just theoretical knowledge. It has practical applications for people living near volcanoes.
Absolutely. These maps are essential for planning, emergency response, and educating the public about the risks.
That's reassuring to know. It shows how science can help us understand and manage the dangers posed by nature.
Couldn't agree more.
Well, I think we've reached the end of our deep dive into the world of volcanic bombs. You've given us so much to think about, from their fiery beginnings to their impact on our planet.
It's been a pleasure sharing my knowledge and insights.
And to our listeners, thank you for joining us on this journey into the fascinating world of volcanic bombs. We hope you've enjoyed this deep dive. Keep exploring, keep learning, and never stop being curious about the world around you.